Good morning. Stats moving along to 2.3 and correlation. So in 2.2, we looked at two variable quantitative data, and we talked about association with the explanatory variable and the response variable. Well, now we're going to look at the correlation of it and how that pertains to our stats class. And again, this should be something that's somewhat familiar to you, how the data correlates with one another, whether it's positive, negative, linear, nonlinear, things that we have seen before. But we're going to talk about in this next slide here how to estimate the correlation between two quantitative variables. And there's some really important information here. Okay, so first thing is correlation R. So we're looking at the variable R right now. Okay, the measure of strength and direction of a linear relationship between two quantitative variables. So we're talking about now a positive and a negative correlation. Negative obviously goes in a negative direction, positive goes in a positive direction, but it always remains between -1 and 1. We never go outside of these two limits. So again, it's always going to be a decimal between -1 or one of these two values if it has perfect correlation. Negative correlation is less than 0, which means it's negative, and positive correlation is greater than 0. If there's very little scatter from the line, R is going to be close to 1 or -1. This is what we would call strong correlation or strong association. If there's more scatter from the line, okay, R is going to be closer to 0. So the closer to 1 or -1 means strong correlation. If there's more scatter from the line, then R is going to be closer to 0. So we're looking at decimals for all of these. And as we kind of move forward, we're going to look at a couple of examples here. Okay, so estimate the correlation between two quantitative variables. So look, if you've got a correlation of 0, it's really difficult to draw a line one way or the other. Okay, so this would be correlation of 0. You can't tell whether it's positive or negative. Very tough correlation. If you look at the second example here, again, they're kind of all over the place, but you could draw a trend line kind of through the middle of that data that's in a negative correlation. And again, the dots are pretty far away from that line on both sides, so that would be -0.3. And then here, the next example, again, I could draw a trend line or a line of best fit that cuts that data in half, and that's going in a positive direction. And again, the dots are still far away, so we would say that correlation is 0.5. As the dots start getting closer together, again, still negative direction, but they're a little bit more clumped together. The correlation gets closer to -1 in a positive direction, gets even closer together, would be 0.9 and then 0.99. So you can kind of see how the correlation affects here, the -0.99. The positive and negative is very important. Again, the closer to 1, the better the correlation, the stronger the correlation is. Okay. So let's take a look at example 1. So saving manatees, choosing a seat. So there's going to be two examples here, this one and then this one. We'll start with this one first. It says, for each of the following relationships, is R greater than 0 or R less than 0? Is it closer to R equals 0 or R equals plus or minus 1? Explain your reasoning. So we've got to make sure, number one, we have an explanation here. The wordage is pretty important, okay? So manatees are a large, gentle, slow-moving creatures found along the coast of Florida. Many manatees are injured or killed by boats. Here's a scatter plot showing the relationship between the number of boats registered in Florida in thousands and the number of manatees killed by boats for the years 1977 to 2013. So as you can see, the more boats that are registered, unfortunately, the more manatees that are killed. Okay, so if you look at this data, hopefully you are looking at this and you see that this is a positive correlation. And for the most part, I would say this is closer to 1 than it is. You might have a couple outliers right here, but for the most part it is. So again, when we're explaining this, because the relationship, so we would say because the relationship between boats and manatees killed is positive, right? Positive, let me spell that right. We can say R is greater than 0. Also, R is closer to 1 than 0 because, again, look at the dots, okay? The relationship is strong. If it was a weak relationship, then we would say that it's closer to 0. Okay, there's less scatter. Okay, there isn't much scatter from the linear pattern. Okay, so not much scatter. From the linear pattern. And it's important for you to use the words linear, if it is linear, okay, closer to 1, and talking about the relationships between the manatees and boats. Okay, example 2, choosing a seat. To see if a seat location affects test scores, a statistics teacher randomly assigned students to seat locations in his classroom for a particular chapter and recorded the test score for each student at the end of the chapter. So teacher just said, hey, I want you to sit here, 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 and here. The explanatory variable in this experiment in which row the student was assigned. So this is the explanatory, okay, where row 1 is the closest to the front. So right here is closest to the front, and row 7 is the furthest away. So you can see these dots are kind of all over the place. However, I want you to notice there's a big gap here and a big gap right here, right? Got a couple of outliers on the edge here and here. So if we look at this, because there's no gap here and or no dots here and no dots here, the closer the student sat, it looks like the better their score. Now, I wouldn't say that's a strong relationship at all, okay? But because of these gaps, if there were dots here, we could say that there's no association or no correlation. But because those dots are there, we can definitely draw a negative correlation, okay? So because the relationship, okay, again, look at the wording, because the relationship between row and score is negative, and this is what was key to notice these two gaps here to make it negative, R is less than 0, okay? Now, for this one, also, R is closer to 0 than -1, okay, because the relationship is weak. Okay, there's a lot of scatter from the linear pattern. So again, make sure that you can explain these in words, and you got to let me know whether it's linear or not. Is there a lot of scatter? Is there not? Is it strong correlation or is it weak correlation? Okay, let's go ahead and move on to objective 2, interpret the correlation. I think this one should be pretty simple, okay, but we've got to make sure we're not ignoring this word right here, interpret the correlation, okay? We've got to make sure that we use the word. So correlation close to 1 or -1 doesn't necessarily mean an association is linear. To determine the form, we look at the scatter plot, okay? So for this example right here, the scatter plot, R equals 0.93, but is the form linear? Okay, we should be able to look at this and show that it is not linear, okay, for this example. So you can see that this is not linear, so it doesn't automatically imply the a linear correlation, okay? So correlation alone doesn't provide any information about the form. The form and the form of association, we got to look at the scatter plot. So this right here is a non-linear, okay? So in interpreting this correlation, we have a strong, so we would say we have a strong correlation, but the pattern is non-linear. Okay, again, anything over 0.8, usually we consider strong correlation. So the scatter plot shows the relationship between 40-yard dash times and long jump distances. The relationship is R equals interpret this value in context. So we want to interpret this in context. Okay. So again, as we're looking at this problem, when it says to interpret, we want to make sure that we use certain words. Okay. So the correlation of negative 0.838 indicates the linear, notice I'm using the word linear relationship because this forms a linear relationship here between the long jump distance and dash time for these students is strong and negative. Is strong and negative. Again, anything relatively over 0.8, 0.75, we would say strong. But again, you got to use the word strong, got to use the word negative, and show the linear relationship. So again, for this last example, strong correlation. Okay, why is it a strong correlation? So we could say a positive strong correlation of 0.93, the pattern of this non-linear, and then describing the weight of the carrots and the price per carat of diamond. Okay, let's go ahead and take a look at the last objective here, and we're distinguishing correlation from causation. This is very important. Correlation does not imply causation. I did this a lot in my Algebra 1 classes. It's just kind of making sure that you knew two things don't really matter, okay? Or they could, but a lot of times they do not. So if we look at this example, this is going to be a little wordy here, but it says for the years 2000, 2009, the correlation between total revenue generated by skiing facilities in the United States and the number of people who died coming tangled in their sheets is 0.97, which is a very strong correlation. Okay. And you can see that it's also linear. Does the strong correlation between these two variables suggest that an increase in skiing revenue causes more people to become tangled in their bed sheets? I mean, hopefully we clearly know that that's not true. But as we're looking at this problem, okay, and describing it, explain our answer. So does it? Probably not. Okay, probably not. Although there is a strong positive correlation. There's definitely a strong positive correlation. Okay, an increase in skiing revenue is not likely, this is an important word, not likely to cause more people to get tangled in their bed sheets. Okay. It is likely that both of these variables are becoming larger over time because of population growth, which explains the association. Okay. So again, definitely probably not, although there's a strong positive correlation. An increase in skiing revenue is not likely. So we're going to use the words likely, not likely when we answer this. And again, it is likely that both these variables are becoming larger over time because of population growth. So we could make that assumption, which could explain the association. So you got a few problems on Edge Elastic to do in 2.3.